Good morning, class. So we're going to start section 2.1 talking about just general vocabulary for polynomials. So most importantly, n, the degree of the polynomial, is the highest power of x. It can have a lot of other exponents throughout the polynomial, but the highest one, that's the degree of the polynomial. A is the letter we use for pretty much all of the coefficients. A sub n minus 1, a sub n, that's all it is. It's just the coefficient of the x. Alright, while there are lots of coefficients, a sub n is called the leading coefficient. It's the one that's in front of the x with the highest exponent. So the one that sets the degree of the whole polynomial, the leading coefficient. Now there are a bunch of other ones. A sub 3 is the coefficient of the cubic term. A sub 2 would be the coefficient of the quadratic term, right? A sub 1 is the coefficient of the linear term. So you just sort of have to be able to look at the a sub some things and figure out which term it's related to. Alright, so we've got the names of the different coefficients, but there's one that's super important. A sub 0. There's no x next to it, which means that's called a, I hope you said constant term. So let's try a couple examples now. So let's see if we can identify those pieces on these polynomials. First, degree. So the degree of this term, I'm going to go to the highest exponent. I'm going to say that the degree is 3. We want to look at coefficients. So the leading coefficient would be that one, a sub 2, coefficient of the square term, and the coefficient of the linear term. Easy? Our constant term is pretty much just 3. Alright, let's look at the second one. We have a degree of 5, right? Alright, so let's look for the other things in here. The leading coefficient, negative 1, right in front of the x to the 5th. A sub 4 doesn't exist. That term's not there, which means that this coefficient must have been 0. Because 0 times x to the 4th would make the term disappear. So let's fill in the rest. A sub 3, right there, 3. A sub 2, oh, another 0. A sub 1, negative 4. Constant. It has an invisible plus, right, plus 0 right after it. The constant is 0. So you've been talking about lines in math class since you were pretty much knee-high to a grasshopper. You ought to be able to tell me what a sub 1 and a sub 0 are in this polynomial function and what the degree is. I'll give you a second, then we'll go for movie magic. It's important to know that lines have a constant rate of change. That's the best thing about them. They climb constantly up or constantly down at the same rate. 5 feet per second. $40 an hour, don't we all wish? So let's talk a little bit about m, because it's the most important thing here. So what's changing then? Well, the slope is really the change in y over the change in x. You've known that for a long time. You usually write it with subtraction. You would say y2 minus y1 over x2 minus x1. Do the 2's and 1's matter? No. It could be y1 minus y2 over x1 minus x2. Pick your favorite. You're just taking 2 points and subtracting the y values and subtracting the x values. You just have to be consistent about which point comes first and which point comes second. You can't change it up partway through the equation. Okay, we're going to look at this example. Write an equation for which it is true that f of 2 equals 6 and f of negative 2 equals 4. And let's assume that this function is a linear function. Well, I would say that you've been given 2 points. They just don't look like points. And if we could write it like points, then we could solve it just like you have every other year. So this one converts to. Now there are two different ways to solve this. You'll find that in pre-calc and calc, more and more often you have options for how to solve things. That's kind of how your teachers got to the point where they could explain things in 6 different ways. They took pre-calc, and then they took calc, and then they took multivariable calculus, and they took a lot. You can use your old y equals mx plus b equation, just like you always have, or you can try to remember and succeed at remembering point-slope form. So the first step to solving either one of these is to find your slope. Let's take the change in y over the change in x. 6 minus 4, 2. 2 minus negative 2, 4. Well, that simplifies to 1/2. So here we go. F of x, we're going to pick this point because I like positive numbers. 6 is my y value. The slope is 1/2. X is 2. And we're solving for b. So your function must be 1/2 x plus 5. Now, if you like memorizing point-slope form, because it comes in handy in a lot of other times, let's go ahead and plug it in. Y minus 6 equals 1/2 x minus 2. We're going to solve. Hooray! We got the same answer! Yay!